and it'll produce its voltage. So I'm sitting here and I'm doing the numbers. I'm saying to myself, geez, how do I figure out the voltage that I want to produce? Because I don't want to just wind wire. So, I'm looking for 30 to 40 to 50 volts, probably 30 to 40 volts. And 22 gauge wire is a good wire. It'll get me up there. Just out of this right here is 14 gauge wire. I don't like to set up with the spool that's in there because it's iron. So iron on iron. I think I really just missed the point there. But on these are aluminum. That's aluminum right there. That's what that is. So on the aluminum, I'll get a better sort of induction, because the iron, I believe on those, were just making magnetic poles on the outside of the iron here. So they were kind of screwing shit up when the magnets came around to these PMHs. I did have the prong end sticking out, so it didn't really matter in a sense, but it did because you're kind of, I wouldn't say stretching the field out, but I guess you are, because it's metal. It's gonna stretch the magnetic field out. So it wasn't good on turning the wheel. But we're really not looking to turn the wheel right now other than by hand. Right now the coils, out of this coil I'm gonna wind with 22 gauge 1,000 turns. We'll do a test on it. The first test I'll do is to check what voltage comes out of this PMH based on how much induction. Now the magnets themselves have a certain induction, so without putting any juice into the coils, we'll check to see what's being made. We'll have a barrier point from that. And then secondly, we'll start, I'll put I'm going to use car battery. That's just going to be a constant. So, but I want to be able to adjust so I guess but I'm only 10 amps there. I want to step up the amperage if that's only 10 amps. So either I got to get a better DC power supply, or I'll use a couple brand new batteries, and this way I have a lot of current I can pull from the batteries, a lot more than I'll ever be able to pull from a DC power supply. So anyway, back to the nitty gritty. So I want to control the inductance that's coming out. That will let me know what 1,000 turns, because it's hard for me to figure. If you guys know how to figure what formula, but I don't think that, I think you have to have both. This is not like they're set up more for a transformer, like my NST, to where everything's calculated in. You got everything. Here you don't have everything. You got different potentials. So this is pretty cool in itself on experimental, especially for everybody who's an Leedskalnin lover, and basically the fact that he even went outside the realm of building rocks, and he learned about what electricity was and how Mother Nature is coinciding with things that he noticed that every piece of matter kind of shared together. So with the inductance being controlled by how much energy we're going to put into, how many volts we put into the coils of the wheel, the pickup is going to, I'm looking to have 12 to 24 solid good volts, but I want to be able to build a coil that's going to give me between 30 and 40 to 50 volts. And what I want to do is take that and go into my electrostatic. And there's something here that I feel that I'm driven to, because here when I make the electrostatic, I'm using the flyback. The best results I've ever came across is going to be my rubber band, my sort of Wimshurst machine, to where it made high voltage. And when that high voltage got separated and it went into this capacitor that I built a while back, if you look back at my videos, I built this capacitor. It's foil on the outside, foil on the end. That's solid grounding wire and just a piece with the foil around it. So basically you've got outside plate, inside plate, and a dielectric. When that energy comes out of that rubber band, this gets so pressurized that when I take my little chicken stick, which is right here, my chicken stick place. When I take my chicken stick and I touch the outside plate and or just go near it, forget about touching, go near it about an inch. And an inch to the inside, this is representing the inside plate. You get a spark that goes across. One that shows me on those sparks are every bit of an 1/8 to a 1/4 inch thick. So that means current. There's a lot of current in there, a lot of pressure, so forcefully there's current. So that current is what Ed, and now I'm going to say me. Let me put this back up here. Yeah, Wimshurst machine material. Ed and me. Me now, because if Ed did this or not, I'm going to do this. So I'm going to take the flyback and do a couple experiments, which is a relationship to a iron pipe with a coil core in it, with a capacitor set up underground, dipped in a chamber that's not touching ground, but electrostatically, inductively close in proximity to the ground. So that means that I would build a box, and the box would be a conductor. And then inside that conductor, where it can't be moved or touched, would be this as a conductor inside. And this inside conductor is fully freaking charged. And the whatever pressure we put on the outside or the inside, so whether the outside is negative or the inside is negative, whatever opposing energy we want to be attracted to that energy is going to be absorbed in. And at that point, you can take that energy, which we call electrostatic, but basically it takes ground, and not only one ground, but takes several grounds. We'll go there and just say dimensionally, you need to introduce different grounds to the electrostatic in order to get it to be current going through a system, a circuit. My brothers, this is exciting. I hope you guys leave your comments. What else? Is there something else I had to tell you? Let me see. So basically, whatever voltage we get with the induction of the magnetism going into this coil, we'll get a voltage. We'll know some numbers there. We're going to take that. We're going to start off with a flyback, which basically a flyback that's making the voltage higher, which is what electrostatics are. Do react to matter. So all matter in the ground is balanced. Think of it that way, is balanced. The only way you get energy to move through that balanced matter, which is the ground you're standing on, to the guy on the other side of the planet standing on, the same matter. It's all connected. The difference is that static is controlling the electron movement through all that matter, and that is from lightning that's constantly smacking the ground around the world. That constant frequency becomes a harmonic, and that harmonic is what we're going to be tapping into with the electrostatic to the ground. So you say to yourself, why we want electrostatic in the ground? Well, the electrostatic in the ground will become part of the Schumann wave. That wave is the wave we're connecting to. So we're not throwing electromagnetic into the ground, which is the opposite of how things are really ran. Then that's what I'm doing. It's basically turning it backwards, because the right side is controlled. The other side isn't controlled, and that's why it's not known. So basically the ground, why, like Ed says, why nobody focuses on the negative? They all focus on the positive. They build all these equipment and run everything, and they just want to be able to be controlled, that everybody needs that positive. Everybody needs that power. Them electrons are going to run everything in your house. There's not a damn thing in your house that you can't, that's controlled. It's all controlled by what? Electrons. Movement of energy. Movement of energy. In which way? The way we run it? Yes, that's how we do it. The way we run it. Don't mean to do a little summarial there, but little preaching. But anyway, yes. So you can figure out other ways, as you guys who develop stuff and are trained and schooled, you can open up your own heart, your eyes, and kind of figure out that if you can think about it, there's a way. Work hard at it. Remember this, everybody. To be successful, 90% of that came from sweat. Peace out.